Now next topic if you're going to learn, that is polymorphism. So I'll take a real life example. What does a polymorphism means? So poly means many, morphism means forms. So which have many forms, that is what polymorphism. I'll take a real life example. Suppose a girl is there. She can be many things. She can be mother, writer, student. A same person can have different roles. That is what polymorphism basically means. So a concept by which we can perform a single action in different ways. Polymorphism can be achieved by method overloading, that is function overloading, and method overriding. So we'll see types of polymorphism also there. So there are two types of polymorphism: compile time polymorphism and runtime polymorphism. We'll understand each one by one. What is compile time polymorphism and what is runtime polymorphism. So here are some of the differences between compile time polymorphism and runtime polymorphism. So the function to be invoked is known as compile time. So in compile time polymorphism is achieved by two ways, like function overloading and operator overloading. The overloaded functions are invoked by matching type of the number of arguments. So this is what compile time polymorphism is. It is also known as overloading, early binding, or static binding. So these are the keywords we use for compile time polymorphism. And runtime polymorphism is also known as overriding, dynamic binding, or late binding. So that is what runtime polymorphism. So we're going to see function overloading in compile time polymorphism and function overriding virtual function in runtime polymorphism. So this is achieved by function overloading and operator overloading, and this is achieved by virtual functions and function overriding. It's provide fast execution as it known as compile time, and it is slow execution because this is runtime. At the runtime, it is run at the runtime. So it is when I talk about compile time polymorphism, it is less flexible as mainly all things are executed at the compile time. This is more flexible because at the this all executes at the runtime. That is what compile time polymorphism and runtime polymorphism. Now we're going to see one by one and examples of compile time polymorphism and runtime polymorphism. So C++ overloading is the compile time polymorphism. So we're going to see example what is C++ overloading is. So in C++ overloading, there are, if we create two or more members having same name but different in numbers or type of parameters, it is known as C++ overloading. So we're going to see for methods, for the functions, and constructor also, that is constructor overloading also. We know that it is because these members have parameters only. So that is what C++ overloading. In the overloading, we're going to talk about function overloading in detail. So when we talk of function overloading, it means the class will have same function name but its parameters or type of parameter will be different, so that compiler will know when we pass value in the main function where to go, which function to call. So that is what function overloading is. When we talk about operator overloading, it means one operator is going to do two different tasks. That is, plus sign is there that can be used for concatenation of the string, and that can be used for addition also. That is operator overloading. So that is what this things means. Now we're going to jump over the VS Code and we're going to see in detail about function overloading. Now let's jump to the VS Code. Now we're going to see function overloading, how it is achieved. Before that, I'll clear the terminal. I'll write clear. All right. Now I'll create one file, that is 16, and write function overloading 1.cpp. So this is the example we're going to see. Let's write without writing the class, let's see what function overloading is. I'll write hash include iostream using namespace std, and I'll write the main function also, int main, and after the main function I'll write it and I'll return the statement also, return 0. All right, this is done. So what we're going to do is, let's create few functions and name the same function name. All right, so let's create a add function, suppose. So I'll create a void and add function, and inside that add I'll give int num1 comma int num2. So these are the parameters I'm passing in this function. So here what I'll do is, I'll create another variable int sum that is going to add these numbers. So num1 plus num2. So these are the variables I've created that is going to add it. Now I'll see out it and I'll write the sum is, and that is going to be printed in sum variable. The sum is sum, and I'll write endl here. All right, so this is what this function is. Now let's suppose I want to create again same function name is going to use, that is void sum. If I use same number of parameters, 2 parameters, and I give type different, that is going to give error. So not sum, we're going to add. So this is polymorphism we want to see. So polymorphism means which have many forms. I took that example if you remember. So here I want to pass, let's say int num1, int num2, int num3. So 3 parameters I am passing. So after that what I'll do is int sum equals to num1 plus num2 plus num3, and this is the addition of 3 values. And after that I'll write cout statement, and I'm going to write it as that the sum is, and sum is going to stored in sum only. So I'll write sum. So this is going to print whatever the result. So here you see two different functions are, same functions are there, but different number of parameters are there. So I already told you that whenever we write same function name, that time it's going to give error. But whenever the parameters are, numbers are different, or type of the parameter is different, that time it is not going to give any error. So that is what function overloading is. So whenever I pass these values from the main function, so it is going to take accordingly, and it is going to go to that particular function. Let's create one more function of the same name, void add, and let's write here as double num1 comma double num2. Here parameters are 2, but the type of that is different. Here parameter are 2, but types are different. So this is also considered as function overloading. It means compiler won't get confused. If I would have used int, suppose any variable name, and int any variable name, that time it would have been given error, because the first function we have used, that is int type int, so that time that would not have been the function overloading. So here I'll write int sum equals to, not int, here it's double, so I'm going to write double sum equals to num1 plus num2. So this is the output it's going to give, and at the right I'll write cout, and I'll say sum is, that is going to be stored in sum, right? I'll write end L. So this all 3 functions have same name, but different number of parameters is there. Hence it is a function overloading. It means the compiler won't get confused if I pass values from main function to this function, so it will accordingly go to whichever function it has. So that is what function overloading is. Now if I come to this and I call this function add, and I give value suppose 5 and 89. So it is going to go to the first function only. So that is what it is recognizing. Now if I call another function add and I'll write it this way, and I'll call another function add and I'll write this way. Alright, now here we see that 3 numbers are there, and that's all are integers, 76, 57 and 89, let's suppose. So it will go to this function only whenever I call. It will not go to this function, hence this is function overloading. So one thing is very clear, that we can write same function name but parameters numbers should be different. Here we see 2 parameters, 3 parameters, integer type. But when parameters are same, the type of that parameter should be different. It is not related with the void or int. If I write int add and if I write void, so return type doesn't matter. The parameter, it's depend on the parameter. Alright, here what you have to pass is, I have to pass the double values. So I'll give 7.6 comma 89.4. So it will automatically go to this function only. I'll save the code, Ctrl S, right click here and run the code. So you see all are giving output. So here if I use endl, so that will come to the next line. Save the code, Ctrl S, right click, run code. Now you see all are giving output, it is not giving error. If I would have been used another this variable, same number of parameters and type should be in that integer, that time it would have been given error. So that is not allowed, that is not function overloading. Now we're going to see function overloading in the classes what we did. In the class, let's create for that. So let's create another program and write is 710 and function overloading dot cpp, function overloading dot cpp. All right, now here we're going to achieve in the class. Let's create class for this. So hash, I'll write the basic template, hash include iostream using namespace std, and I'll write int main and I'll write the return 0 at the last, 0. Alright, now we have to create class for this. Let's create a class name as dog. So class dog I have created. Alright, after creation I'll give semicolon at the end so that it doesn't give error. Then we'll create the data members. I'll name the data members to be in access modifier to be public. So I create a string data member string and I write sound, that is one data member I write, and I'm going to write int age. This is the second data member I write. Now I'll create another function, that is display, and inside that I'm going to do is cout, I'm going to write is barking. So I'm writing barking in this function and I write L at the last. Alright, so this is done. One thing I have written, one function. Now I'm going to create another function, let's say void display only. And inside this function has no parameters if you see. Now we're going to give some parameter here. Let's give string sound here. Now if I write inside this function and I'll write cout statement and sound is, I'm going to write that is sound, that is stored in the sound data member, right? And I'll give endl at the last. Alright, this is the one function. Now I'm going to create another display function, same function name, void display, and inside this display I'll write cout statement, and inside that I'm going to write age is, and at the last I'll give age and I'll use endl at the last, and we have to pass the parameter also. So here I'll be passing the parameter that is integer type and age. If you see one parameter is here, one parameter is here, this will not give error in the function overloading because it's a string type, it's an integer type. And here no parameters are, so this is all are different display. Whenever I call, so it will be called accordingly. So it will recognize that no conflict is there. Now if I create another display, let's say void age, not void age display function, and inside that let's create int age1 comma int age2. Suppose I create two data members, like two parameters inside it, and I write cout statement here, and I write age 1 is, that is going to be stored in age 1, and I'm going to write what age 2 is, and that is going to be written inside age 2. And after that, what I'm going to use is end L. Alright, these are the four different functions, and all have, this has no parameter, it has one parameter, it has one parameter, so no conflict because it's a string type, it's an integer type, and it has two parameters. So all are ready for function overloading. And from the main function, we're going to create object for that dog. So for creating object, I'll write dog, I'll write d1, and I'll write d1 dot display this function. So when I write no parameter inside it, so first function will be called. If I write d1 dot display again, and I give data type to be string, that is if I write dog how it's bark, so if I give how, so it is going to print that way only. So it will go to that particular functions only. So when I write this, only one string is there, so it is going to print this one. When no parameter is passed, so it will go and it will recognize this function. Same function but different parameters and type of parameters there. If I write d1 dot display again, and inside that I'll give suppose 8 as the age, so it is going to the integer, this one only. Alright, now if again d1 dot display is there, and I give suppose 8 comma 9, so it is going to go to this function only. Alright, now I save this code, Control S, I'll click here, I'll clear the code. After that I'll right click here and run the code, and after running see barking is getting printed, sound is bow, age is 8, age 1 is 8, age 2 is 9. So all are getting printed accordingly. So no conflict is happening. This is what function overloading is. Thank you. Now we're going to see next topic is function overriding. So if a derived class defines same function as the defined in the base class, is known as function overriding. So we see function overriding in an inheritance. So we're going to create an inherited class, and we're going to see same function when it's inherited, and when we create object for the child class and we call that same function, so how the result is giving. So we're going to see that. So it is achieved through runtime polymorphism, and it enables you to provide specific implementation for the function which is already provided by its base class. So that is what function overriding is. Now let's jump to the VS Code and apply this function overriding and how it is achieved. Now let's see the example of function overriding is. So I'll create another function, the program, that is 18 function overriding .cpp. Alright, so function overriding on the other hand occurs when a derived class has a definition or one of the member function of the base class. That base function is said to be overridden. So function overriding occurs when a function of the base class is given new definition in a derived class. So what I mean by that is we're going to see that. So let's create the basic template for that. So I'll write hash include iostream using namespace std, and I'll write the main function int main, and I'll write the return 0 at the last. Alright, so this is the basic template we have created. Now we're going to create a base class or parent class or super class, whatever you want to say. So class base. So this is the base class, and here we'll create one function that is going to be overridden in the child class or derived class. I'm going to write is public as the access modifier, and inside that I'm going to create a function that is going to be, so let's suppose, void type. So it is returning nothing, so I'm writing void. I'll write display as a function name, and inside the display I'm going to write cout statement, and here I'm going to say is base class display function, base class display function. Alright, after that what I'm going to write is, we're going to come out of this. Now we're going to create a child class or derived class for this. So I'll write class derive, and we're going to create child class. So this is derived class is the child class. Basically derived class you say, child class or subclass you say, that all are same thing. So it is inheriting from base class. So I'm going to write is public, and I write base. Now here it's going to inherit this display function, member function. Now here I'm going to write public, and what I'm going to do is, again I'm going to create void display function, same function name. I have to come to the next line. So I'll come into the next line. I created the display same name function I have created in the child class also. Now here I'll write cout, and I'm going to write it as derived class display function. Alright, this I have written down. Now if you see, when I say derived class, it is going to inherit all the properties, public properties of this base class. So display function, so two same display function is coming. Now when I create object for this derived class and I call this display function, so which will be called? So that time that derived functions, like derived class display will be called, display function, member function will be called. So we're going to see, and we're going to print how to do that also, that how to print the derived like base class display function also. Then I have to write derived as the class name, and I'll create object. Let's say d1 is the object. So d1 dot display, when I write, so it is going to call that, it is going to call this function. But we know this child class have two display functions. This display function is internally hidden here inside this derived class, and this display function is there. Now we created what? We created the derived class object, and when we call it, and let's save the code first. Save, right click here, run the code. When I run the code, it is saying, it is printing derived class display function. So this is an, like you might be seeing, finding that why this display is also not getting printed, base class or display function, because this derived class have this display function also and this display function also, but it is calling derived class display function. If you see here, it means here function overriding is happening. Now if I want to call this above display function, then what I have to use is, let's see, then what I have to write is, here is, I have to use the object d2 dot base, and I have to use scope resolution operator. When I use double colon, that is what is called as scope resolution operator. And what I'll do is, I'll call that function display, and I'll call this. Now if we see, now that will be called. So here I am writing, here I'll create one more object that is going to be D2. Now if I write D2.base and scope resolution operator, then for the derived class object we're going to call this thing also. Let's save this code, Ctrl S, right click and run the code. After running the code, see derived class display function and base class display function both are getting printed. Base class display function. So this is what is printing base class. So this is what function overriding is, because you see derived class will have this display function also, this display function also internally. Now when I call, simply that time this derived class is getting printed, this cout statement is getting printed, but same display function is there. So to call this same display function, what I have to do is I have to create another object D2, and after that D2.base I have to write this class name and scope resolution operator and display. That time it will print that. So this is what function overriding is. I'll clear the thing and I'll run it again. Let's run the code. Now if I run the code, if you see, both are getting printed. Base display and base class display function both are getting printed. All right, thank you for this one.